You ever just stare at a block of code and feel completely lost? You're looking at Python, you want to learn it, but you just have no idea where to even begin. Trust me, that's a totally normal feeling. It's like being dropped in front of a pile of construction materials and being told, okay, build a house. But what if you had a blueprint, a clear step-by-step plan that shows you exactly how to go from a simple foundation all the way up to a towering skyscraper? Well, that's exactly what we're going to do here. We're going to reframe learning Python not as this impossible mountain to climb, but as a totally achievable construction project.
Every great build starts with a solid plan, right? So this first part is all about the fundamentals. These are the architectural drawings, the specs you have to know inside and out before you even think about breaking ground.
Okay, let's pop open the toolkit. Think of your keywords and variables as the nuts and bolts. They're the fundamental little pieces that hold absolutely everything together. Your operators, those are your power tools. They're what let you do the actual work, like adding things up or comparing them. Input and output are kind of like your communication system, letting your program talk to you and show you the results. And finally, comments and indentation, they might seem small, but they're the precise measurements on your blueprint that keep your code organized and readable. You have to master these first.
Now think of these data types as your actual building materials. I mean, you wouldn't build a window out of concrete, right? It's the same in Python. You've got different materials for different jobs. You use numbers for math, text strings for text, lists to hold a bunch of items in order, and booleans for simple true or false questions. Picking the right material for the job is absolutely critical.
All right, we've got our blueprint, we've got our materials. Now it's time to start framing the structure. This is where your code really starts to take shape and, actually do stuff.
To get that frame up, we've got two main tools. On one side, you have decision-making, using if, elif, and else. This is like your code walking down a hallway and deciding which door to open based on a certain condition. On the other side, you've got loops. This is your construction crew building the 10th, 11th, and 12th floors super efficiently, just repeating the same plan over and over. One is about making a choice, the other is all about repetition.
So the frame is up. That's awesome. But building every single tiny piece from scratch is just not efficient. It's time to work smarter, not harder, and bring in some prefabricated parts.
This simple idea right here is honestly one of the most powerful concepts in all of programming. Why would you build the same staircase 10 different times when you could just design one perfect staircase and install it wherever you need it? That's the whole idea behind what we call functions.
So yeah, a function is basically a pre-built window unit. You design it once, you get the dimensions right, the right kind of glass, the right frame, and then you can pop that window function into any room, on any floor of your building, just by calling its name. It is the ultimate tool for efficiency.
But what if you didn't even have to build that window unit yourself? Well, that's what modules are. These are entire toolkits, pre-stocked with amazing functions written by other expert developers. Need to do some crazy complex math? Just import the math module. Need to work with dates and times? There's a datetime module for that. It's like having a whole team of specialists on speed dial.
Our skyscraper is getting pretty tall now, which is great, but we need to make sure it's strong, safe, and can handle anything that gets thrown at it. This is where we shift from just building to engineering.
And that brings us to something called object-oriented programming, or OOP. This is a really powerful way to organize big projects. Instead of thinking about scattered materials, you start designing self-contained objects. Like you can create a blueprint for an elevator object that knows what floor it's on and has actions like go up and go down. It's a brilliant way to bundle data and behavior together, making complex stuff way easier to manage.
Now, OOP is built on 4 big ideas. Encapsulation just means keeping everything an object needs bundled together neatly. Abstraction is about hiding the messy details. You just press the elevator button, you don't need to know how the motors work. Inheritance lets you build a new object based on an old one, like making a freight elevator that has all the normal elevator features plus some extra strength. And polymorphism, it's a fancy word that just means you can use different objects in similar ways. Together, these make your code incredibly flexible.
But what happens when things go wrong? A power outage, a leaky pipe. In programming, that's where exception handling comes in. Using try and except is like installing your building's safety systems. The fire alarms, the sprinkler systems. It makes sure that one small problem doesn't bring the whole building crashing down. Okay, our building is up, it's strong, it's safe. Now for the really fun part, adding those high-level, super impressive features that make it a true landmark on the skyline. This is where we call in the heavy machinery.
Libraries like NumPy and Pandas are like these massive construction cranes that let you lift and manage huge amounts of data with almost no effort. And Matplotlib? That's your team of graphic designers who can create stunning visuals and charts from all that data your building is processing.
And finally, we have the finishing touches. These advanced concepts are what separate a functional building from a true work of art. Learning things like list comprehensions or decorators is like installing the high-end interior design and the smart home automation that makes your project truly next level.
So there you have it. We went from the basic blueprint to framing the structure to adding reusable parts, making it robust, and finally, reaching for the skyline. As you can see, learning Python isn't some dark art. It's a construction project. And the best part is, you now have the full set of plans.
The blueprint is officially in your hands. You've got the tools, you know the materials, and you understand the whole process from the ground up. So the only question left is, what amazing thing are you going to build first?